Hey guys, I got a couple of requests to do a video for this worksheet because some of you are having trouble with it. So I acquiesced and am going to do problems number 2 and 3 to compare a weak, strong reaction to a strong, strong reaction. So one thing I hope you noticed about this worksheet is that it tells you exactly what's going on. It tells you I have a weak acid reacting with a strong base in problem number 2, and it tells you I have a strong acid reacting with a strong base in problem number 3. So you didn't even need to look up a chart telling you about the strong acids and strong bases or try to figure it out. It was all laid out for you, which is pretty nice. So to look at problem number 2, we're going to start out with the complete ionic equation because that's the first thing it asks you to do. So the 3 things it wants you to do, 1 is write out the complete ionic equation, 2 is write the net ionic equation, and 3 is to tell yourself, hey, is it going to end up being acidic, basic, or neutral when everything is said and done? So to write out the complete ionic equation, you have to first know what you're dealing with. So in this case, we're dealing with a weak acid reacting with a strong base. And what that means is that your acid is not going to ionize completely in water, but your strong base will ionize completely in water. So the first step then for you is to identify which is which. So hopefully you are aware that pretty much anything with an OH or a hydroxide in it is a base. So our NaOH, our sodium hydroxide, is our base here, and our HNO3 is going to be our acid. So since it's a weak acid, when we write out the complete ionic equation, we leave that alone. It remains HNO3. It does not split apart because it is a weak acid. However, our NaOH, our sodium hydroxide, does split apart. So we end up with our Na plus and our OH minus. And then we do the product side. So a couple of things to keep in mind with the product side. Water is never, ever, ever going to split apart in solution because it's just water. So you leave that alone. You just write H2O. The second thing that you have to be aware of is that any salt will automatically split apart in water. And a salt, to remind everybody, is a non-metal or an anion bonded to a cation or metal. So in this case, our cation, our metal, is sodium, and our anion is nitrate. So those things are automatically going to split apart. So we're going to end up with Na plus, and we're going to end up with our NO3 minus over there. And then you start crossing stuff out because that's how you go between the complete ionic equation and the net ionic equation. But you are only going to cross out things that appear in ionic form on both sides. So in this case, we're going to cross out sodium because sodium appears in ionic form on both sides of this equation. We are not going to cross out our nitrate because nitrate only shows up on the right. It's bonded to something else on the left, so you cannot cross it out. So when we rewrite our net ionic, we are going to be left with everything except sodium. So we're going to have our HNO3 plus our OH minus. And then that's going to yield our water and our nitrate. So what this should mean to you all overall is, 1, we crossed out the sodium because it's not technically part of the overall direct reaction. It's there, but it's what we call a spectator ion, so it doesn't actually do anything. It's just present. What we're left with is the things that are directly going to be reacting together. And now you'll notice that on this side, we are left with extra OH minus that is not neutralized by an H plus. So that means that overall, when everything is said and done, we're going to end up with a basic reaction overall. That solution that we end up with is basic. So moving on to problem number 3, when we have a strong acid reacting with a strong base. Now, in this one, when you have a strong acid and a strong base, both the acid and the base are going to ionize completely in water. So you automatically start splitting stuff up. Now, for this, we have HF. So when we're writing our complete ionic equation, we need our H plus and our F minus. But you see this 2 here. That means that we have 2 molecules of HF. So to give you a visual on the side, we have this going on. So since we have 2 of these molecules, overall, when that splits into its ionic character, we're going to have 2 H pluses and 2 F minuses. So you have to make sure to translate that coefficient down to your complete ionic. So we're going to end up with 2 H plus and 2 F minus. And then there's no coefficient in front of our calcium. So we just have 1 calcium. But we have 2 of our OHs in that molecule. So you're going to translate that subscript into a coefficient. We have 2 of those. All right, and then on the product side, once again, water is never, ever, ever going to split up. So you have your 2 waters. And we have our salt, and once again, salts always split up. So we have our Ca plus, and once again, you have that subscript that you have to translate into a coefficient. So we have our 2F minus. And then we're going to start crossing stuff off again. So this time I'm going to go from right to left. We have H plus on this side. We have no H plus on that side, so we leave it alone. We have our 2F minuses on this side, 2F minuses on that side, so we can go ahead and cross those out. We have Ca plus on this side and also on that side, so we can go ahead and cross that one out. And we have our 2 OH minuses on this side, but no OH minuses on that side, so we leave that alone. Now we go ahead and we rewrite our net ionic with everything that is left, so we are left with 2H plus and 2 OH minus. And that is going to go ahead and yield 2 waters. Now, the difference here between this and the thing above it is that, yes, we have OH minuses on this side, and yes, we have H pluses on this side, but we have the same amount of each, so those are going to neutralize one another. There's no extras left over on either side. So in this case, when everything is said and done, we end up with a neutral reaction. If we had had, for whatever reason, let's say 3 OH minuses on this side, like if this had been a 3, then that would have been basic overall because we would have had an extra OH minus. Or if this had been a 4 or something, that would have made it acidic overall. But since we only had our 2 and 2, so let me rewrite that. Our 2 and our 2, it is completely neutral. So I hope that was helpful. Please feel free to email me with any questions you may or may not have still, and I will be more than happy to help you.